Every morning Earth lights up thanks to the bright sun. The sky glows blue, the world awakens, and sunlight pours over everything we see. It's easy to think that the sun's brilliance must fill all of space, lighting up the universe just as it does our planet. But if you've ever seen photos taken from the International Space Station, or watched astronauts floating above Earth, you'll notice something strange. The sky around them is pitch black, even when the sun is shining right there. Why is that? Even when it's night here, the sun keeps shining out there. The sun never stops burning, sending out energy in all directions, bathing the solar system in light. So, if the sun is always shining, why doesn't space itself glow with that same light? So why doesn't space glow too? Why, when we look up from the moon or from orbit, do we see endless blackness instead of a bright sunlit sky? Stars like our sun produce their own light. They are gigantic nuclear furnaces, fusing hydrogen into helium and releasing enormous amounts of energy as light and heat. This light travels outward in all directions, filling the universe with photons. And our galaxy alone has over 500 billion stars. Imagine that. Billions upon billions of stars, each one a sun, each one shining across the vastness of space. If you add up all the galaxies in the universe, the number of stars becomes truly mind-boggling. Trillions upon trillions, each pouring out light. Planets don't shine, they just reflect starlight. When we see planets like Venus or Jupiter glowing in the night sky, we're really seeing sunlight bouncing off their surfaces or clouds, not light they make themselves. With so many stars and planets, space should be bright, but instead it looks almost empty. The night sky, even through the most powerful telescopes, is mostly black, with only tiny pinpricks of starlight scattered across the darkness. It's a cosmic paradox, a universe filled with light, yet appearing so dark. To see something, light has to reach our eyes. On Earth, sunlight scatters in the atmosphere, lighting up the sky and making it blue, but in space there's no air to scatter the light. Light travels in straight lines, and unless it hits something, like a planet, a spacecraft, or your eyes, it just keeps going. You've probably noticed the Doppler effect with sound. A siren changes pitch as it zooms by. This happens because the sound waves are compressed as the source approaches and stretched as it moves away. Well, light does something similar. When objects move toward or away from us in space, the light waves they emit get squished or stretched, changing their color and energy. If a star moves toward us, its light shifts blue. This is called blue shift, and it means the light's wavelength is getting shorter, carrying more energy. If it moves away, it shifts red. This red shift means the light's wavelength is getting longer, carrying less energy. The faster something moves away, the more its light is stretched. When astronomers looked deep into space, they found that almost every distant star shows a red shift. This was a huge clue about the nature of our universe. That means the universe is expanding, actually stretching space itself. Galaxies aren't just moving through space, the very fabric of space is getting bigger, carrying galaxies apart like raisins in rising dough. As space expands, the light traveling through it stretches too. A photon that started its journey as visible light millions or billions of years ago gets pulled apart, its wavelength growing longer and longer as it crosses the universe. It starts as visible light, but over millions or billions of years, it becomes infrared. Then radio waves, stuff our eyes just can't see. The universe is full of this invisible, stretched-out light, but to us, it's as if it's disappeared. So, even though stars shine constantly, their light stretches and fades across the universe. The farther away a star or galaxy is, the more its light is redshifted, until it's completely invisible to human eyes. That's why space looks black to us. The light is still there, but it's been stretched so much by the expanding universe that we can't see it anymore. What we see as darkness is really a sea of invisible energy. And here's the wildest part. The universe is actually expanding even faster than the speed of light in some regions. This doesn't break the laws of physics because it's space itself that's expanding, not objects moving through space. Some distant galaxies are moving away so fast their light will never reach us, no matter how long we wait. They're crossing the cosmic horizon, vanishing from our view forever, their light stretched beyond detection. So, space isn't empty. It's just full of invisible light, stretched beyond what our eyes can catch. The universe is awash with ancient photons, relics of the Big Bang and the lives of countless stars, all hidden from our sight. The universe stretches faster than our eyes can keep up. The darkness we see is really a story of light's long journey, of cosmic expansion, and of the limits of human perception. Like and subscribe if you want more cosmic science, and let's keep exploring the darkness together. The universe is full of mysteries, and every patch of black sky is a window into the incredible story of space, time, and light.